Here we have a function f of x that is defined piecewise. That is, it is defined by this algebraic rule when x is less than 3, and it is defined by this algebraic rule when x is greater than or equal to 3. So first of all, let's find the values of this function at some different points. F of 0. So our input here, 0, is less than 3, so we're in this bit of the function. So in that bit of the function, we substitute the 0 into the x minus 2 squared part. We get minus, this is going to be minus 2 squared, so 4. So we get minus 4. F of 3, when our input is 3, we're in the second part of the function. So it's going to be 3 minus 4, which is minus 1. F of 4, again, we are in the second part because 4 is bigger than or equal to 3. So we get 4 minus 4, which is equal to 0. So we have found a root for our particular equation here. Now we need to sketch the graph of this function. So we know some points on this function. I'm going to write it down again just here so we can see it. F of x equals minus x minus 2 squared when x is less than 3, and x minus 4 when x is greater than or equal to 3. If I put in some axes first of all so we can get a general idea of what's going on here. Now we have to draw these two pieces separately. First of all, I'm going to draw this piece here, minus x minus 2 squared. So what does that look like? Well, that's a quadratic. It's a negative quadratic, so it's upside down, and it's got a maximum at 2, 0. So at 2, 0, which is in the domain of this part, it goes through the root, it goes down, and we know it goes through a y-intercept of negative 4, because we worked that out in part A. And then it's going to carry on going this way, but it's only going to go until 3. For this part, we have the equation of the line is x minus 4. We know the root is at 4, so it's going to come through here at 4. And it's going to come up like this, through 4 there. Now, how do we know that they meet at the same point? Well, we have to work that out. We know that at 3, this one is equal to minus 1. If we were to put minus 1 into here, we'd get minus 1. So if we were to put 3 into here, we'd get 3 minus 2, which is 1. 1 squared is 1 minus 1. So indeed, it does meet at this point here, which is 3, minus 1. And there we've got a sketch of our graph, the two separate pieces that make up this piecewise function. Write down the domain and range of this function. Well, if I scroll up so we can still see that. The domain is going to be, well, we can input any value of x in here. So it is all values of x. So the set of x such that x is a real number. The range, what possible values can we get out of this? So which y values can we get? And again, this is going to keep going down, this is going to keep going up, so we can actually get all possible y values out of this. So the all set of y values such that y is a real number. So piecewise functions are defined this way, where they're defined by multiple different algebraic rules to define different parts of the domain. And the graphs will look like a combination of those different rules in different bits of the graph.